Hello everyone, this is Ray. Welcome to the first episode of the video tutorial series. Today we are talking about site modeling. And before we found this workflow, we are really struggling to accurately represent our site topo and also aerial conditions. So this workflow will use Civil 3D, ArcGIS Pro, Rhino, and Grasshopper, but with very simple processing within each software. So this is the roadmap of how we gonna do this. So the most important thing is to keep a consistent coordinate system. That's through the whole process. And then during once you know your site boundary, you can create a bounding box for your site in Civil 3D, and that's for a couple of reasons. First, a lot of our work for the landscape and master plan, and some early studies for architecture, we are all using CAD, and Civil 3D is basically the same as CAD. You can open the same file, DWG file. And also you can embed or X-reference civil drawing into your drawing. And if you share the same coordinate system, all the civil drawings should pop into the right location automatically. So that's to set up a great communication between civil, landscape, architecture early study, and master plan. And then in Civil 3D, you export that bounding box, the boundary of your site, into shapefile. So you can then import that shapefile into ArcGIS. Before you process any data in ArcGIS, you need to try to find some good quality data from online, either LiDAR or DEM file, which is digital elevation model files. Usually, government agencies and universities will have DEM file ready for you to use. But if you want to have super high resolution DEM, you can go back to LiDAR and generate your own DEM. But this won't be covered in this episode. Once you have the DEM, that's basically a black and white, usually, image. Use the white to represent the high area and the black to represent the low area. And that gives you a value between 0 and 255. That's the z value of the site. In GIS, we will generate a grid of points and add those z values where this point is located on. And this grid of point will become a accurate representation of the DEM. But this depends on spacing between the points because we always want balanced file size and accuracy. And then you export this grid of point to Rhino and use Grasshopper to generate a surface. And last, you apply a aerial as a texture to that surface. And that will wrap up this workflow. Okay, so let's go ahead and see how it works. At first, I download a bunch of information here. So under GIS, I download some high resolution aerial and also a 1.4 meter resolution DEM. This is 2005 for St. Louis High Point area. So I'm thinking to use that as the base. And to follow the steps, I will open Civil 3D. I'll choose Imperial and create a new file. And you can see here, sometimes it's in drafting or annotation. You want to pick on Civil 3D. And I'll close my X reference for now. And here, under settings, you can right click on your drawing. We can edit the drawing setting. Under the zone area, you can find from this drop list to find the site you want. So we will choose Missouri And from this drop list, we'll find 983 East Zone US foot and hit OK. Now if you zoom out, you will see a red dot. That means this drawing is coordinate system related. If you just tap in GeoMap and turn on the aerial, and hit yes, it will load the map into your drawing space. And from here, you can find the areas you want to draw. I'm thinking to somewhere here, including part of the urban condition and also the forest portion of Forest Park. Okay, before I draw the bounding box, I want to see where my DEM landed on this area. So I will open ArcGIS and create a new map. I'll call it high. The first thing is also to go to the properties and set the coordinate system to here. You can just search usually under projected coordinate system. You can find 983 US feet and choose east. So you can see the whole world is reprojected. Okay, and go to catalog. Need to add a new folder. Add this whole folder here. Add the aerial. Also add a DM. Just hit OK. Okay. That's the data I downloaded from online. Yeah, it covers where I want map. So does the aerial. I don't know why this aerial is a little weird color. Okay, we probably won't want to use this one. I want to, originally I want to cover this in the next episode, but since we have this issue, I created a link so you can link Google Map into GIS. It's a layer file under portal. You can drag this layer file to a map. And that's the most current Google map. Okay, let's go back to Civil 3D. I will draw a bounding box. I'll draw maybe 2000 by 2000. And to export this geometry, if you're happy with the bounding box, you can use map export. Under GIS, I will create a new folder called shapefile. And here you want to check polygon and select your bounding box. And go to options and treat closed polylines as polygons. And you can check if this is the coordinate system you want. Okay. So now if we go back to our folder under shape, we can see the shapefile is already exported. So we can go to ArcGIS, go back to project folder, and we want refresh the shapefile. You can drop the bounding box into your GIS map now. And we probably want to change the display a little bit. Okay, just see, okay, covers what we want. Okay, so the next step, we will Go to Tools to generate a grid of points. The command here, you can search for create fish net. We can save to its default location. Just call it a grid. And the extent we want using the bounding box, so we only generate the points within this bounding box. And the cell size, since we have like a 2000 by 2000 feet area, it's always good to go from big to small. The smaller, the more accurate it is, but sometimes it will take forever. So I choose 5 feet apart for the points. Choose the same coordinate system. Extend bounding box and hit run. It will create label. Label is the points, and the grade is the grade itself. We can remove this one. So these are all the points. But if we right-click on the layer and open the attribute table, we can see currently it's only have the point ID, do not have the Z value. So if we go back to our diagram, we need to add the value to this grid of points. We will go back to Tools and search for a tool called Add Surface Information. And the input feature, we want to have the points, and input surface is the DM file. And we want the Z value to add it to these points. And extend is the same bounding box. Leave default, this one. Just hit run. Now if we open the attribute table again, we can see the Z value here. But one thing we need to keep an eye on, this is in meters, not in feet. The easy way to check, you can search, you can Google the site elevation, or you can use Google Earth to cut a section and see the elevation, just to make sure you are in the right unit. Here we know it's meters, so we will translate that into feet. To do that, we can add a new column here called elevation. And we can choose either double or float. I will choose double for now. And set to numeric. And decimal 6 usually is fine. And hit OK. After you've created this new column, just click Save. Now you have a new column of data ready for you to process. And right-click on that. Go to Calculate Field, and you want double-click on Z. That's the value you want to add to this column. Basically, copy this column of data here, but times differences between meters and the feet. And hit OK. We'll do the calculation. All right. Can go back to Tool, export to CAD. We want to export both the grid label and bounding box. choose the coordinate system, bounding box. Okay, hit run. Okay, it's ready. Depends on how large your set is and how accurate your grid points are. It may take some time. And I can drag it open with Rhino. Feed is fine. Okay, so this is the point. It looks like a point cloud. And now we will change this point cloud into a surface. So if we load Grasshopper, it's one very simple component called points to surface from points. Add a point component to it. And since we have 2000, sometimes if your bounding box is not a whole number, will be harder. But basically, you will use your 2000 divided by the cell size, which is a distance between 2 points, which is 5. You get 400. So we'll generate a 400 by 400 grid. And we'll select all the points, attach to it. And you can turn off the grid and create a new layer. We can call it a surface. And bake this surface to the layer. We can close this Grasshopper. And that's your surface. You can see it captures the fine detail of the site. If you think like this representation is too busy, you can turn off the grid. The next step is to apply the right aerial to this surface. To do that, we need to go back to ArcGIS. And here we have the Google Map layer turned on. And we need to go to, we need to create a layout. Go to New Layout, Customize, Page Size. Thinking 36 by 36 would be big enough, but you can go to even higher. Okay. You can add a bookmark or not. Maybe add a bookmark is better. And here you can drop in the map frame as your bookmark and onto this layout. You can see our red bounding box is better to see in this layout. A quick way to clean up that is go to the property of your map and create a clip layer and clip to an outline and choose your bounding box and hit apply. Okay. And that will crop out all the other information you don't need. So here we can take a better look of the aerial. And you can see here we have the boundary of our drawing frame. We don't want that as well. So we need to transparent, change to 0. We have a clean one, and we want this to be as big as possible, but leave some space to the edge. So we can try to tweak this number here. That'd probably be a better way to do this. If you know, please let me know. $700. Okay. Okay, I think that's pretty good. And we can export this image now. So we go to Share, Export Layout, and we want to choose PNG and check Transparent Background. And find the folder we can put under Rhino. Just call to Site Texture. And you can tweak the DPI. Usually I think 72 works for the most of the time, but if you want to have a little bigger, you can do 150. Today just for speed, I will do 72. And you can hit export. This also impact the file size a lot. If you have super high resolution image as a texture, your Rhino file can be really large. So you want to balance that as well. Okay, it's finished. We go to our Rhino here. So that's the image we generate. Actually, there's a transparent frame. So we want to fix that. Open Photoshop. Open that file. Sometimes we'll have some credits underneath here, but this one do not have, so it should be easier. Go to Image Trim, trim out all the transparent pixels. Okay, now we have a clean texture ready for our model. So export to PNG. Find the file. Maybe crop. Okay, it's only 14 megabytes. Not bad. And the quality is okay, I think. You can close Photoshop, go back to Rhino, go to top view, and change to shade display. And under material, we can choose create a new material. Call this site texture. This one. Seems already correct. Just double check. Okay. Now that's our surface with high resolution, up-to-date Google imagery, but it captures like the valley. There's a lot of information already here. If we want cut contours, you can. Usually, once you finish creating the site like this, you want to create a layer called origin. Give a vibrant color, put a point. Make sure it's not project. And to your bounding box corner or anywhere you will remember, make sure to lock that layer and move the whole scene from this origin to 0, 0, 0. You can see actually our model is far away from the model space center in Rhino. Because everything we created has a real geolocation. That's why it costs this. In this way, you can always move things between the real origin and the model origin. Okay, that's it. Good night. To find a good DM file online, I think you can start with Spatial Data Information Service. And under here, you can go to like it have imagery data, LiDAR data. This is for Missouri only. You can also go to their open data portal. If you scroll down here, you can download imagery and LiDAR data through a map view. To download our site information, we can go to High Point area and uncheck this. We want DM, LiDAR DM, and it will click here. You can see all the available data for this location. So we have 3 files available. One is the one I'm using. It's a little bit old, 2005, but higher resolution. You can also use 2012 and this one 2017. So there's also a balance of like most current or higher resolution, depends on the area. And to download imagery, you can, let's say what, 2 feet index, or you can check here and we'll have a bunch of options. This is 2015. It also have 2020, but it's, well, usually not super high resolution. You can also go to Worcester GIS department. They have research guide, help you find data online, and you can find local area, state, area photography, or even global. Will kind of direct you to some good website. But also you can go to the county GIS open data. Usually the county or the city government agency will have higher resolution for their local area. Okay, that's how you can find some GIS information online.